Imagine a perfectly routine morning. It's June 12th, 2025. A Boeing 787-8 Dreamliner Air India flight AI-171 is just moments from takeoff in Ahmedabad, heading for London Gatwick. Everything seems completely normal, a standard flight, until suddenly it wasn't. Today, we're doing a deep dive into the preliminary report from India's Aircraft Accident Investigation Bureau. It's about that Air India B787-crash. Now, this report it's packed with critical information, but it can be pretty complex. Our mission here is to help you cut through that, understand the key findings, and really grasp the sequence of events leading up to this tragedy based on this initial data.
Yeah, and it's really important upfront to understand what a preliminary report actually is. It's based purely on the initial facts and evidence they've gathered so far. And the report itself states clearly, this information could change as the investigation goes on. Its only objective, the sole purpose, is accident prevention. That's it. It's absolutely not about assigning blame or liability for what happened. The report even warns against using it that way because you could easily come to the wrong conclusions. The focus is data for future safety.
That's a really crucial point to keep in mind. So, okay, with that framework, our focus today is unpacking those initial findings. We want to piece together that timeline and explore the immediate and, frankly, profound questions that this preliminary data raises. We're here to guide you through it. Let's start with the stark facts. The accident happened June 12th, 2025 at 08:09 UTC. That's 13:39 local time, Indian Standard Time, right there in Ahmedabad. The flight was Air India AI-171.
And the human cost, it's just devastating. All 12 crew members, that's the 2 pilots and all 10 cabin crew, suffered fatal injuries. Of the 230 passengers, 229 were fatalities. Just 1 passenger survived with serious injuries. And tragically, it didn't stop there. 19 people on the ground were also killed, and another 67 seriously injured. The scale is just immense.
And the international nature of this kicked in immediately, didn't it? Which tells you something. The NTSB, the U.S. National Transportation Safety Board, got involved right away because, Boeing is U.S. designed and manufactured. They sent an accredited representative, plus technical advisors from Boeing itself, GE, who made the engines, and the FAA. And on top of that, the UK, Portugal, and Canada also got notified because they had citizens among the fatalities.
Exactly. And following those notifications, an investigation team was put together very quickly. And this wasn't just any team. It included a whole range of subject matter experts, SMEs. We're talking experienced pilots, engineers, aviation medicine specialists, flight recorder experts. You need that breadth of knowledge.
Right, brings all the pieces together. Okay, let's talk about the aircraft itself. It was a Boeing 787-8 registration VT-A&B manufactured back in 2013. And it had flown quite a bit, over 41,868 hours total. Importantly, its Airworthiness Review Certificate, the ARC, was issued very recently, May 22, 2025. So it was considered airworthy.
And looking at its maintenance, the last major line checks, the L11 and L12, were done around 38,500 hours. The next really big check, the D check, that's like a major overhaul, wasn't actually due until December 2025. Also worth noting, both engines were relatively new installations. The left one went in May 1st, 2025, and the right one March 26, 2025. So pretty recent.
Okay, and what about its operational status right before this flight? Any MEL items active, the minimum equipment list?
Right, the MEL. So for people who might not know, this list basically allows certain non-critical components to be inoperative for a limited time, provided safety isn't compromised. On this aircraft, VT-A and B, there were 4 Cat C/Ls. Category C usually means you have about 10 days to fix it. These were things like the flight deck door camera, the airport map function, core network, the printer. Minor stuff, relatively speaking. There was also one Cat AAL, which is a bit more restrictive, related to nitrogen generation performance. But crucially, all these MELs were active and valid. They didn't ground the plane.
So mechanically sound, recently certified, recent engine installs, MEL items, all within limits. Okay. This makes the next part, potentially very significant. Can you walk us through this special airworthiness information bulletin, the SAIB, about the fuel control switches? Why is this suddenly so interesting?
Okay, yeah, this is where things get complicated. The FAA issued this bulletin, SAIB NM 1833, way back in December 2018. It specifically warned about a potential issue where the locking feature on the fuel control switches on 787s could disengage. Now, the key thing here is, this SAIB applied to this aircraft type, yes, but it was advisory. It wasn't a mandatory airworthiness directive, which would have required action. And according to Air India, the airline stated that the inspection suggested in that advisory bulletin, they were not carried out on this specific aircraft, VT-A and B.
Wow. Okay. So an advisory about a potential switch issue existed, but the recommended checks weren't done because it wasn't mandatory?
Exactly. And while maintenance records show the throttle control module was replaced in 2019 and 2023, the reasons given weren't related to this fuel switch issue. And importantly, there were no reports of any defects with the fuel control switch itself on this plane since 2023.
Hmm. So a known potential issue flagged years earlier, but no mandatory action taken. Keep that detail in mind, everyone, as we get into the flight itself, because what the data recorder shows happened next is, well, it's quite extraordinary. Let's set the scene for the flight. The plane had just arrived from Delhi. There was a minor maintenance issue, a STAB POS XDCR message, something to do with a stabilizer position sensor. That was fixed, troubleshot successfully, and the aircraft was cleared for the flight to London. The crew, the pilot in command, the PIC, was a 56-year-old male, held an ATPL, the highest license. The co-pilot, a 32-year-old male with a CPL, was the pilot flying for this leg. And, crucially, both were rested, confirmed fit for flight. They passed the Stanley Birth Analyzer test.
Right. And the air traffic control recordings give us a very clear timeline leading up to the takeoff. Pushback request was at 07.43 UTC. ATC asked if they needed the full runway length at 07.49. They said yes. Taxi clearance came at 07.55. They were told to line up on runway 23 at 08.03, and then cleared for takeoff at 08.07.3 UTC. Winds were light, 240 degrees at 6 knots, everything completely routine.
Okay, now for the takeoff roll itself. This is data straight from the Enhanced Airborne Flight Recorder, the EAFR, the black box. It's incredibly precise. 08.07.37 UTC. Aircraft starts rolling. 08.08.33 UTC. Crosses V1, that critical decision speed at 153 knots indicated airspeed. Just 2 seconds later, 08.08.35 UTC. Hits VR, rotation speed at 155 knots, the nose comes up. 08.08.39 UTC. Liftoff confirmed. The sensors switch to air mode. And then 08.08.42 UTC. Reaches maximum recorded airspeed of 180 knots, just 3 seconds after liftoff.
And this is the moment. Precisely at 08.42 UTC, immediately after hitting 180 knots. The EAFR data shows Engine 1's fuel cutoff switch moving from RN to CTOF. Just 1 second later, Engine 2's fuel cutoff switch does the exact same thing, RN into CTOF. And as you'd expect, the data then shows engine speeds N1 and N2 starting to decrease rapidly. Fuel supply was cut.
And then there's the cockpit voice recorder, the CVR. You hear one pilot asking the other why they cut the engines. And the response, a clear denial. He did not do so.
Yeah.
I mean, that's just chilling. You have the machine saying one thing, the data showing the switches moved, and the pilot saying, I didn't do it. How do investigators even approach that?
That contradiction is, well, it's the absolute heart of this investigation right now. It's a huge challenge. They have to meticulously analyze everything. The CVR context, tone of voice, background sounds, timing against every single parameter from the EAFR.
Yeah.
It forces them to consider multiple possibilities. Was it an uncommanded system malfunction that a pilot accidentally hit the switches? Was it some kind of, spatial disorientation or stress response? They can't assume anything. It's about understanding precisely what happened in that cockpit, mechanically and cognitively, in those critical seconds.
The immediate result was catastrophic. Airport CCTV actually caught the ram air turbine, the RAT, deploying during that initial climb. That little emergency propeller pops out when engine power is lost, providing basic hydraulic power. It's a last resort system. And significantly, no birds were seen near the aircraft. So a bird strike seems unlikely as the cause here. The aircraft then started losing height very, very quickly. Before it even got past the airport boundary, we're talking seconds.
But there was an attempt to recover. The data shows it. At 08.08.52 UTC, so just 10 seconds after the first cutoff, Engine 1's fuel switch moves back from cutoff to run. 2 seconds later, 8.08.54, the APU inlet door starts opening the auxiliary power unit the tail is trying to auto-start, likely triggered by the loss of main engine power. And then 2 seconds after that, or 8.08.56, Engine 2's fuel switch also goes back to run.
Okay, so fuel's flowing again to both engines. Did they relight?
Yes. The FAGE, that's the Full Authority Digital Engine Control. The engine's computer initiated a relight sequence for both. You see the exhaust gas temperature, EGT, rises on both engines, which indicates fuel is burning. They're relighting. Engine 1 actually started to recover. Its core speed stopped decreasing and began to increase. Engine 2 also relit, but its core speed kept decelerating initially. The FADE kept trying, reintroducing fuel, intending to accelerate it, but it couldn't arrest the speed loss sufficiently in time.
Not enough time. At 08.09.05 UTC, just 9 seconds after the second switch went back to run, one of the pilots makes the call, Mayday, Mayday, Mayday. The EAFR, the black box recording, stops just 6 seconds later at 08.09.101 UTC. ATC saw the crash and hit the crash alarm. The aircraft came down on the BJ Medical College hostel, less than a nautical mile from the end of the runway. And another tragic detail. The emergency locator transmitter, the ELT, which should activate on impact, it didn't activate in this crash.
The scene itself. The debris field was huge, about 1,000 feet long by 400 feet wide. It tells you the aircraft broke up violently. The initial impact sequence seems to have been with trees, then an incineration chimney, before hitting the wall of Building A at the college. Based on marks on the building and wreckage, the impact attitude was likely nose up, maybe around 8 degrees, with the wings roughly level. Just tremendous force involved.
And the pieces were scattered everywhere. The vertical tail fin landed 200 feet away from that first building impact. The rear fuselage section and the right main landing gear were actually embedded in Building A. The rest kept going. The right engine hit a concrete water tank and separated completely.
Yeah, and other parts tell the same story. Right wing parts in Buildings A and B.
Huh.
The left main gear and left wing sections hit Building C. The nose gear ended up over 300 feet from the initial impact. The left engine hit Building D at ground level. The main fuselage just fragmented across multiple buildings C, D, E, F. A complete structural failure.
Now, amidst all that destruction, they did find some cockpit controls. What did those tell us? The flap handle was found in the 5-degree position. That matches the EAFR data for a normal takeoff setting. And the landing gear lever was found in the down position.
Right. But here's where wreckage analysis gets tricky, and it highlights a key point investigators always face. While the thrust levers in the wreckage were found near idle, likely due to fire damage melting the connections, the EAFR data is crystal clear. They remain fully forward at takeoff thrust right until impact.
Ah, okay. So the physical position in the wreck doesn't match the recorded data just before impact.
Exactly. And similarly, both fuel control switches were found in the wreckage in the re-end position. But we know from the EAFR data they were moved to cutoff and then back to run moments before the crash. It really underscores why the flight data recorder is so critical. Impact forces and fire can completely change how controls look afterwards, potentially giving a misleading picture if you only looked at the wreckage. You have to trust the real-time data.
Makes sense. So the investigation is obviously ongoing. What about the recorders themselves? The forward EAFR, despite heat damage, was successfully downloaded. That gave them about 49 hours of flight data and the crucial 2 hours of cockpit voice recording covering the accident flight. But the aft EAFR was too damaged to download conventionally. And it sounds like the NTSB's help was vital here, providing special gear, a golden chassis, to get that data off the forward unit. Shows how tough recovery can be.
Absolutely. And as for next steps, the on-site wreckage work is done. Everything's been moved to a secure facility for detailed examination. Both engines were recovered and are quarantined, waiting for teardown and analysis. Fuel samples from the refueling trucks and tanks tested okay. They're still trying to test some limited fuel samples from aircraft components, but that needs specialized labs. They've also gathered witness statements, including from the one surviving passenger, and they're analyzing the post-mortem reports for all the crew and passengers. It's a painstaking process.
So, bringing it back to the core mystery, given what we know from this preliminary report, the data shows fuel cutoff. The pilot denies it. How central is resolving that contradiction to finding the cause? And what are investigators focused on if they can't make recommendations yet?
Oh, it's absolutely central. That discrepancy, EAFR data versus CVR statement, is the critical point right now. Investigators will be poring over every millisecond of data, every nuance in the voice recording, looking for anything that could explain it. Was it mechanical? Was it human factor related? An interaction. They have to build the complete factual sequence before they can determine why it happened. And that's why the report explicitly states, at this stage, there are no recommended actions. They're not ready. They need more evidence, more analysis to be certain about the cause before telling operators or manufacturers what to change. It's about getting it right.
And that really leaves us and you, the listener, with this central puzzle, doesn't it? You have this state-of-the-art aircraft, experienced pilots, clear weather, then bam, sudden engine power loss right after getting airborne. A frantic attempt to relight, to recover, and that haunting denial from the cockpit amidst the chaos.
And just remember, the ultimate goal here, the reason for this meticulous work is prevention. It's not about finding fault. This preliminary report lays out the sequence, the observations, a detailed picture of the failure. But it leaves the fundamental why unanswered for the full investigation to determine. It's step one.
So as you think about this deep dive, consider that detailed timeline, the conflicting data points. What factors could it be purely mechanical failure? A human element under immense pressure? Or maybe some complex, unforeseen interaction between the two could possibly lead to such a rapid, devastating chain of events at the most critical phase of flight. What hidden layers might still need to be uncovered before we truly understand what happened on Air India 171?